Alright, hello guys, welcome to my YouTube channel. Today I'm going to be teaching you guys how to make your very own smart bin. Alright, this is Jexy. I made Jexy a few months ago, and due to some serious occasions or series of occasions, I've not been able to make a video yet. But this is Jexy, and today I'm going to take you guys through the electronic components and the connections of Jexy. So in this video, we're going to have 4 tiers to it. Tier 1 is going to be the components and the connections to the bin. And tier 2 is going to be the coding. That's going to teach you guys how, or teach you guys every single line of code that goes into making the bin functional. And then the third part is going to be the design. We're going to design this with Fusion 360. I'm going to make detailed designs. And the last part is going to be the rendering, where we're going to render every single design we make with Blender 3D. Right, so we're going to have 4 tiers in this. So yes, this is a smart bin. It just opens up when it detects an obstacle in front of it. As time goes on, we'll make improvements based on your preferences. So join me as I take you guys through the components and the connections of this particular video. And also I'll take you to the coding aspect too, so don't worry, I've got you covered throughout the video. Stay tuned. Alright, so I'm going to start by explaining how the code functions in this particular project. All right, so the first line includes Servo. This is a very important line. This allows us to control the Servo motor. All right, it's basically like a Servo library. All right, without this library, the Servo won't work. That's basically it. All right, and then we go to the Servo dustbin. Servo, right? This very one, Servo dustbin Servo, right? So that's there to represent the motor that opens and closes the lid, all right? And then we have to define our pins we are going to be using in this particular project. So the trig pin, the echo pin, and the Servo pin. Remember, the trig pin is going to be in relation to the ultrasonic sensor. The echo pin is also going to be related to the ultrasonic sensor, and then the Servo pin would also be related to the Servo motor, right? So you go to the next one, which is the void setup. All right, so with the void setup, the void setup is a one-time action, I'd say. And then with the pin mode, we've set the trig pin to be our output, and then the echo pin to be our input. All right, and for that's been Servo, we attach the Servo pin to it. Servo pin is being defined over here as pin 6. So instead of writing trig pin, echo pin, we could basically use 9, 10, and all those stuff. But why we've made a trig pin and echo pin is because if there should be an error anywhere and we come to change these values over here, it automatically affects every single line of the code. But if you make it individually, like here, trig pin, you make it 9, the next part you make it 10, you are going to change every single part where it appears in the code. That's why we've just made it like this. All right, so the that's been Servo right 120. That is the degree at which the lid closes. So based on your design, you are going to tweak the angle to your preference. Mine, it goes to 120 to signify it's fully closed. That's why I made it 120 for closing. All right, and then that is it for the void setup. For the void loop, this is the part of the code that runs endlessly. So it runs over and over and over and over again. That's basically for the void loop part of things. All right, so for the void loop, digital write trig pin is set to low. Low is I'd say off. All right, low is off. If in Arduino, if you say low, it means off. If you say high, it means on. Right, and then it's going to be off for 2 microseconds. It's going to be delayed for 2 microseconds. Then it comes on. All right, and it delays again for 10 microseconds, and then it goes off again, just like that in a repeated form. With the distance is equal to duration part, 0.0344 is the speed of sound in centimeters per microsecond. Then we divide that by 2 because the sound goes to the object and back. All right, it goes to the object and back. So to the object and back, that's where it makes that 0.0344, that speed. And then we want it only in one direction, not forwards and backwards. That's how we divide it by 2. All right, so the result is the distance in centimeters. Good. So we go to the distance. For the distance part, it's set to centimeters. So then we've made it in this way that if it measures the distance to be lesser than 70 centimeters, it should turn the dustbin, like it should open it. All right, basically it should open the dustbin to an angle of 45 degrees. Based on my design, if the motor turns to the 45 or the 45th degree, it means it's fully open. It means the bin's lid is fully open. Else, if it doesn't record this particular distance or lesser, not this particular distance or lesser, if it doesn't record a value that is lesser than 70, it should stay closed. It being closed is when it's at 120 degrees. All right, then it delays for 300 microseconds and then it restarts again. Remember, it's a loop, so it goes in a closed circle, like an infinity symbol. Sorry, it's it's basically the design of the Arduino IDE. So yeah, that is the coding part of it, and I'm going to take you guys through the connections through using the Tinkercad. All right, that's where we are going to upload this code and then simulate what we've done and see if it works properly. If it works properly, then we can transfer it to real life and then use it, expecting it to work as well. In that case, if it doesn't work, we know it's not the fault of the code, but it's rather the fault of either the microcontroller, a sensor, the servo, or maybe the wiring you've done. So you should be very, very careful with those things. Anyways, I'm going to be taking you through the connections part of it shortly. Stay tuned. All right. So first of all, you go to Chrome, and then you type Tinkercad, right? And wait for it to load up. All right, got it. Good. Then you type on the, sorry, you tap on the link address, the address to it, yeah. And when it loads up, if you have an account, you can log in. If you don't have an account, you'd have to sign up, right? So I have an account, I'm going to log in. You can decide to log in with your Autodesk account or Google. And I feel like it's easier using your Google account, so I just log in with Google. Okay, good. Now we are logged in, all right? And let's just, I've already made it, but let me try creating it from scratch so you know how it's been done, all right? Sorry. So I think I didn't explain this to you. Let me go back so you really grasp everything. So when you go to create, you have the option to create 3D models, create circuits, and then also create code blocks, all right? So we go to the circuits part of it, where we can get all our circuit boards and every other thing, join them together, add the code to it, and then simulate it virtually to see if it works, right? So for this, we are going to be using an Arduino for our smart bin system, right? That's going to be the microcontroller of our smart bin system. And then after that, we would also need an ultrasound sensor. Sorry, so over here it's called an ultrasonic sensor. I'm sure that's the right thing. And then we also need a servo motor, right? So a servo motor is actually there to for you to be able to control the angles at which you want the bin lid to open up. and then the ultrasonic sensor is also present to measure the distance between the obstacle and itself. So it's being programmed by you, all right? So based on our code, we are going to be using, so here, sorry, these are your wires, all right? And then these are the color codes for your wires. So I'm going to start with yellow, all right? So with yellow, based on our color code, we are going to connect that to pin 10, all right? And then we connect it to the trig. There it is. This looks like a different ultrasonic sensor. We don't need this. All right. We need the one with the 4 pin because that's what basically every single person has access to. All right, I think this is it. Yes, this is it. So we go back for our wire, which is already set in yellow. We go to pin 10 and then we connect it to the echo pin. Sorry, it looks crooked. We can still fix it up. You fix it up by straightening it, all right, and doing the same thing here, and it looks perfect. Then the next thing, we go for orange, which is connected to pin 9, and we take that to the trig side of it. Ooh, all right, okay. Oh, that is very bad. It did not fully connect. It's still. All right, let me just delete it and then redo it again. So we go to pin 9 and then we take it to the trig. Okay. This looks good, just a little bit slided. Good. Then we go for, for your ultrasonic sensor, you have a VCC pin and then you have the GND pin. The VCC pin is the power or the voltage that has been supplied to it, and the GND is basically ground, which is negative, right? So with the power supply, we'd go in for 3 points. No. All right, so the ultrasonic sensor, for it to run at optimum efficiency, would have to go for the 5 volts option, all right? So you'd click on the 5 volts slot, and then you take it, you lead it directly to the VCC of the ultrasonic sensor, all right? Then we go and then we change make sure you've deselected the line before you change the color, because if you have the line selected and you change the color, it's going to affect the line, right? So you deselect it by clicking anywhere on the screen and then choose your next color, which is black. So we look for GND on the board, which is here. We have 2 GNDs. So we can just pick one and then take it to the GND parts of the ultrasonic sensor. All right, good. This is looking good so far. All right, so now we go to the servo motor part of it. So with the servo motor, the orange port is where information is being transferred from the microcontroller, which is the Arduino Uno, to the servo motor. That's the channel where it communicates. That's where it tells the servo motor what angle to actuate to, right? So we connect that part as well to pin 6 based on our code, right? Connect it to pin 6, which is somewhere here. All right, then you can just straighten it up, make it look professional. Good. Then we go for the next one, which is black, right? And then we connect it to the GND part of the microcontroller. Good. All right. Yeah, much better. Then pick the red, and then we connect it to the 3.3 volts of the microcontroller. Somewhere here would be fine. And yeah, that is it. All right, and I think this side too. Good. Now tell me this doesn't look professional. This is so professional. This is how you guys should be wiring your stuff. All right. So now we have to get the code part of the code part of the entire system. Okay. So from this part, we go back to the Arduino IDE and then we copy the code we've already created over there, right? Then we come here. This is already set to block codes. We are not coding in blocks, we're actually coding in text. So we select text. Are you sure you want? Yes. Don't really have to read everything, but you can read if you want to. I'm just not reading it. So we copy that code from the Arduino IDE and then we paste it here. Okay. Then we have it pasted here and then we try simulating it. Come on. You can just close the code and wait for it to initialize. All right, good. So it's working now, right? So let me bring this down a bit. Okay. So you see what happens. So when we go back to the code, based on the code, all right, it is supposed to, the servo motor is supposed to be actuated if it senses a distance lesser than 70 and lesser than 70 centimeters, which is outrageous. I know it is outrageous because we were actually designing this for a bigger bin, not the small ones we have at home. Because if you're going to stand 70 centimeters away from a tiny bin, well, technically it's still good because it's less than a meter, right? A meter is 100 centimeters. And 70 centimeters, I think it's fine. I think it's fine for a normal bin, right? So we close the code part of it again, and then you can be looking at this side, all right? Currently it's at 100 and something, so you realize this closes, right? When you drag it closer and then it goes below the 70 mark, this opens up. That's the same thing. That's what happens to the bin, in the bin side, all right? So it senses the distance lesser than 70 centimeters, and then it sends that information to the Arduino Uno, which is a microcontroller right now. And that information is being processed and then transferred to the servo motor, telling it which angle to be actuated to. So basically that is it for Tinkercad. It makes it very, very simple for you to understand every single electronic component you're trying to work with. Tinkercad also has some downsides because it doesn't really have every single component you think it has to have. So normally we have to use Proteus at a point in time. We have to use Proteus. Proteus is quite technical. It's for like engineers, like senior engineers and stuff. Honestly, I am not that good at it. I just know about it. I've not really delved into it yet. But if you know about it, let me know in the comments and let me know if there's probably a video or something I could watch to help me better myself at it. Anyways, this is what we have for the electronics bit of it. That's the Tinkercad part of it, and I hope you enjoyed this video, and I'd like to see you in the next one. Thank you. And don't forget to like, share, and subscribe to our YouTube channel.